In this video, we're going to be talking about transformations. So you essentially have a function and you're going to be changing some attributes of it in the vertical and the horizontal direction. Let's say we have a function y that is equal to f of x, and our function is going to take an input and it will produce an output. So what you need to know is if you manipulate an input, it's going to cause a change in the graph horizontally. Now, if you manipulate an output, that's going to cause a change in the graph horizontally, or vertically, So let's say we have an output transformation that is vertical. So these are going to be outside of the function. What I mean by that is, in this example, we have y is equal to f of x plus 3. And this is your function. And we have an addition of 3 on the outside of the function. So what this means is that every y value changes and our graph is going to move vertically. So our rule for vertical shifts are that y is equal to, for example, f of x plus k. And if you have a positive value for k, you're going to shift your graph up. And if you have a negative value for k, you're going to move downwards. So let's take another example. So for this example, we have f of x is equal to x cubed or squared plus 4. So what happens is that every output becomes 4 larger. Let's say we have this table of x. This is going to be y, and this is going to be our new y. So we have 0, 1, and 2. Then we have 0, 1, and 4. So after this, we are going to add 4 to each of the values. We have 0 plus 4, 1 plus 4, and 4 plus 4, giving us 4, 5, and 8. So our graph is going to shift 4 up. Let's talk about vertical stretch / compression. This is when we have y is equal to a f times x. A is going to be greater than 1. That is going to be a vertical stretch. If you have 0 is less than a is less than 1, you have a vertical compression, so smaller. And if you have a is less than 0, you're going to have a negative value for a. That's a reflection over your x-axis. So this is something that can be combined with the 2 above. So you could have one of these, and then you can also stack that with a negative. Now, let's look at an example of this. If you have y is equal to 3x squared, what we're going to have is that this 3 is going to cause every y value to triple. So let's look at this with a table. If we have x here, and then we have y is equal to x squared as our originally we had 1 and 4 for 0 and 1, or for 1 and 2. Then our y new is going to convert 1 times 3 is 3. And then we have 4 times 3 and that's going to be 12. It's important to note that these are our y values that we are going to be multiplying by, not our horizontal values. So now let's talk about reflection over an x-axis. So if you have y is equal to negative f of x, this is going to cause all outputs become negative. So, for example, if you have a negative value, you're going to multiply by negative, that's going to become positive now, right? And then you have negative value and a positive value. That's going to become negative, right? So that's going to swap those values. So for example, let's take if we have y is equal to negative x squared when originally we had y is equal to x squared. So we have 1 and 2 for x. So our old y, we're going to have 1 and 4. Now for our new y, we're going to have 1 times negative 1. And we're also going to have 1 times negative 4. We get negative 4 and negative 1. So what happens is the graph flips upside down. Now, what if we have input transformations? These are going to affect the horizontal and occur inside the function. For example, we have y is equal to fx minus 3. That's on the inside. It's causing horizontal movement. So what you have to know is they are going to be the opposite of what you think intuitively. So, for example, if you have a horizontal shift, y is equal to fx minus h, your graph moves left by h units. Now, on the other hand, if you have y is equal to fx plus h, the graph is going to move. Here is actually it's going to move right, and then here we're going to move left. So it's going to feel backwards because the inputs are changed. Now, why is it backwards? Well, for example, if we have f of 2 is equal to 5, and we have, looking at g of x, is equal to fx minus 3, to get the same output 5, x minus 3 is equal to 2, x is equal to 5. So our point is moved from 2, 5 to 5, 5. Let's look at another example. So let's say we have f of x is equal to x squared, and we want to transform g of x is equal to x minus 4 squared. So let's particularly look at our vertex. We know originally our vertex is going to be here, 0, 0, and then it's going to become 4, 0. So what about a horizontal stretch or compression? Our rule is we are going to have a function, and inside we have b times x. So it's also going to affect x values oppositely. If you have a positive value, you're going to have a horizontal compression. And if you have a value that is in between 0 and 1, that is going to be a horizontal stretch. So if you have y is equal to f2x, we can say everything happens twice as fast horizontally. So what happens is our points are squeezed toward the y-axis. So let's look at this with the table. If we have x 1, 2, y 4, 7, we are going to have g of x equal to f 2x. So to get old input of 1, we would have 2x equals to 1, right? So x is equal to 1/2. So what happens is we had the point 1, 4, and that is going to become 1/2, 4. So we are going to divide our x values by 2. So now let's write down all of our transformations we have so far. Y is equal to a f b x minus h plus k. A is on the outside. That is your vertical stretch compression. If you have a negative a, that is going to reflect over x-axis. H is inside. That is your horizontal shift. You have a B on the inside. That's horizontal stretch compression. And if you have a negative inside, this is going to mean you reflect over your y-axis. And the K is going to be a vertical shift. Now, if you have plus K, that is always on the outside, that's vertical. Multiplying by A on the outside, that is vertical. X minus H on the inside, that is horizontal. And multiplying X by B, that is horizontal. And something important you should note for B specifically is usually you want to factor this out before you graph and analyze your transformations to see those transformations clearly. Overall, on the outside, we have normal, intuitive, responsive to our graphs, but on the inside, we are going to have opposite. So let's look at an example of how to transform some points. If we have originally a b on y is f of x, let's say we want to do a vertical transformation. So if we have y is equal to 2 f of x plus 5, we have the same x, but our y is going to change. We have b is going to become 2b plus 5, so our point is going to become a 2b plus 5. Now, let's say we have a horizontal transformation. Now, this is going to be for y's f of x minus 4. We're going to have an x changes from a to a plus 4. Now, y is the same. So our point is going to become a plus 4 and b. Now, if you have, again, reflection over x, that's y is negative f of x, this is going to negate your output over x-axis. Now, what about over y-axis? That is, you have something on your input. That is going to negate your input. For example, y is equal to f negative x. You have 3 of 7. 3, 7 is going to become negative 3, 7. So let's do some examples of reading transformations from tables. Let's say we have originally x and then f of x, 1, 2, 3, 2, 5, 8. So let's say that our new in our first example is equal to g of x, and we're taking all the old values and adding 4. So if we have here, we can add g of x, and you're going to take 2 plus 4. You're going to take 5 plus 4, and then 3 plus 4, giving us 6, 9, and this is actually 8 plus 4, which is 12. So let's say we have a second example where we have fx minus 2 is equal to g of x, and this is our new value. So code this. This would make our old point 1, 2, right? So this time we're going to have 3, 2, and 4, 5. That's because we're going to take our x. We're going to call that x new. It's just going to be the same values, except we have 1 plus 2. And then that's going to equal to 3. Then we have 2 plus 2. That's equal to 4. 3 plus 2. That's equal to 5. So it's just going to be the opposite of what we think is right intuitively. So we can see we have that 3, 2, and then 4, 5 using those fx values. You had 1, 2, and then we had 2, 5. Makes sense. Now let's do another example. Say we have g of x is equal to f 3x. That's a horizontal compression by 3. So our old point is going to be 3, 8. And then our new point would be 1, 8. You would just divide by 3. Now, let's do a shift right by 5. So then what this means, shift right by 5, is going to be a horizontal transformation. So this is going to become f of x is equal to x minus 5. You don't want to do it on the outside. It's the inside. Now, let's say we have a question that asks us to go up 3. Now, you're going to do this on the outside. This is vertical. This is f of x is equal to x squared plus 3. Now, let's say we want to go reflect over y axis. Now, this is going to be a horizontal flip. So, I mean, that's a vertical flip. I mean, no, that's a horizontal flip. I don't know why I said that. So you have y is equal to negative x squared, which simplifies to y is equal to x squared. it's going to be unchanged because of a parabola being symmetric. So what about the order that you do transformations? Well, when you do transformations, let's go back here. What you want to do is usually your horizontal first, and then secondly, you want to do vertical stuff second. But when you're graphing your points, your horizontal changes x values, right? So your x is going to be x over b plus h. Now in the vertical, you change y values. So y becomes ay plus k. Now, that's it.